write down that today is Unit 4, Day 4. It's our 4th day of working on conic sections. And we're going to spend one more day on hyperbola. One more day on hyperbolas today. Okay, I'm going to work one where we change from general to standard form, and then I'll work 2 puzzle problems, so just 3 questions today. All right, grab your graph paper 2, and let's label your next graph paper as hyperbola number 3. Okay, and I'm going to number my notes kind of funny today. I'm going to start with number 3 so that it will match up with your graphs. Okay, so I'm not going to start with number 1 today. I'm going to start with number 3 because yesterday we did 1 and 2. All right, so let me give you a big long equation to start with. So number 3, we're going to take a look at 9x squared minus 4y squared minus 18x minus 16y minus 43 is equal to 0. Okay, so I'm going to take that big long equation, I'm going to change it into our formula format, and then we'll take a look at the graph. So we'll graph one more hyperbola today. Okay, again, we're going to spend some time next week on this, but just so you know, I know that this is a hyperbola because my number in front of x squared and y squared are different, and there's a minus sign in between. So we just talked about the numbers in front of x squared and y squared being different with a plus sign in between, but this time I have a minus sign in between. That's how I know that this is a hyperbola. All right, so I'm going to start by getting my x's together, and then I'm going to get my y's together. And then I'm going to move anything that doesn't have an x or a y over to the other side. And when I move that over to the other side, it will change the sign. So watch out for that. Okay, very much like the ellipse, I cannot complete the square until I have x squared and y squared by themselves. So I'm going to take the 9 off of my x squared, which is going to leave me with 2x right here. Okay, now be careful, because on the next part, with a hyperbola only, I'm actually taking out a negative 4. When I do that, it's going to leave me with positive y squared and positive 4y. Okay, so watch for those sign changes. On a hyperbola, when you take out the second number, it's going to change the sign of what you have all the way through. So it's going to change that from a negative 4y squared and a negative 16 to both of them being positive. And that's going to come back and haunt us again in just a few minutes. Okay, so hold on to that idea for just a minute. Okay, I'm going to keep my 9 that's in front, and I'm going to complete the square on my x's. I'm going to keep my negative 4 in front, and I'm going to complete the square on my y's. Okay, so let's bring down x. I'm going to take half of my middle term right here, including the sign. So half of negative 2 gives me negative 1. Right, then I'm going to square to fill in the blank. So 1 squared gives me 1, but what did I actually add right here? 9, that's right. Remember that I actually added 9 because I have a 9 in front of my parentheses, and if I were to distribute that, I would end up with a 9 over here. So I actually added 9 to the left. I need to then add 9 also to the right. Okay, now over here. Again, I'm going to take half of my middle term, including the sign. So half of positive 4 gives me positive 2. Okay, then to fill in the blank, I'm going to square. So 2 squared gives me 4. Now here's where that's going to haunt us again. be careful right here because this is actually adding in a negative 16. Do you see that? Okay, if I were to redistribute my negative 4, I would end up with a negative 16 right there, which means I need to subtract 16 over here. Okay, so be very careful. With a hyperbola, the first number with x, or this first number, you'll add over, but the second number you'll subtract over. Okay, and if you add all of that together, you end up with 36. Okay, what's my hyperbola formula equal to? 1. Good. Okay, so to get 1, I need to divide by the 36. Again, what you'll start to notice is that these kind of end up flip-flopping with each other. Okay, so 9 goes into 36 4 times, and 4 goes into 36 9 times. Okay, so you end up starting to see those kind of cancel out and give you those numbers back. It doesn't happen every time, but occasionally, or often, I should say. Okay, so there's my formula right there that I'm going to graph. Okay, so switch your brain because we just worked an ellipse problem. So switch your brain from ellipse to hyperbola. Think about some of the differences there. Okay, what they have in common is our center point. So our center point is still going to be HK. So what's with X and what's with Y? Opposite signs. Okay, let's go ahead and grab your graph paper. Grab your graph paper and let's graph that center point at 1, negative 2. So 1, negative 2 is right here. Okay, with a hyperbola, we have to decide if we're going left and right or up and down. Okay, because x is first, which way am I going? Left and right. That's right. Good. All right, so I know that my hyperbola are going to look something kind of like that. Move my computer back a little bit. Sorry, I'm running out of space. Okay, I know that they're going to be left and right. And for a hyperbola, I also know that A is first. A is first. So with an ellipse, A is bigger, but with a hyperbola, A is first. Okay, doesn't matter bigger or smaller, just A is first. Okay, so A is going to be 2, and B is going to be 3. Okay, so I only need 2 vertices. To find them, I'm going to go left and right, this A value of 2. Okay, so on my graph, from my center point, I'm going to go left and right, my A value of 2. All right, so grab your graph, and I'm going to go left and right 2. So 1, 2, and 1, 2. Okay, so 2 vertices. Okay, so let's go and name those. Again, I'm not picky about which order you name them in. It's fine either way. So that's going to be at negative 1, negative 2, and at 3, negative 2. Excuse me. Okay, let's talk about our foci. So for my foci, I need to find C. My C squared equation for this is A squared plus B squared. So remember, I'm going to use the opposite sign that I had up here in my original formula. Okay, so this one's a minus, this one's going to be a plus. Okay, let's plug in what we have. So I know that A squared is 4 and B squared is 9. So I get that C is the square root of 13. Okay, what two numbers is 13 going to be between?
3 and 4.
That's right, good. Yeah, 9 and 16, good. So 3 and 4, good. Okay, so between the square root of 9 and the square root of 16, so between 3 and 4. Okay, again, that's a good enough approximation for our graph. Okay, so I'm going to go left and right because that's the direction we're going here. So I'm still going to go left and right between 3 and 4. All right, so I'm going to go left, 1, 2, 3, and a little bit more. And I'm going to go right, 1, 2, 3, and a little bit more. Okay, I did that with my x value because I went left and right. So use your center point. So my center point was 1, and then plus and minus the square root of 13, and my y value stayed the same. So my y value did not change. It's still going to be at -2. Okay, questions on foci? Okay, the last thing I need for hyperbola is my asymptote equation. All right, let me write down one more time the format. You can write this down if you want to. But this right here is the point slope formula that you learned in Algebra 1. Okay, that's the point slope formula. That's what I'm filling in. Okay, so it's not a new formula. It's one that you already know. It's just a new way of filling it in. Okay, so I'm going to get y from up here in my original equation with y. Just don't bring the squared with it. So I'm going to get y plus 2. I'm going to leave m blank just for a second. And I'm going to bring x over here to work with x minus 1. Okay, don't bring the squares with them. It's just a line. All right, let's talk about slope. So my slope, in this case, with x being first, is going to be b over a. I know that because it's the number underneath y on the top. The number underneath y is always on the top, because if you think about slope, you're doing rise over run. Okay, so the number on top should be with y, the number on bottom should be with x. Okay, so in this case, that's going to be plus and minus 3/2. Okay, and again, you can leave that formula exactly the way that it is. It's actually easier to use in that format. Okay, so I've already got my point at 1, -2. Okay, we've already graphed that. And now I'm going to graph my slope of positive 3/2 and negative 3/2. Right, so go over here on your graph. And I'm going to go up 3, 1, 2, 3, over 2. And I'm going to go down 3, -2, to get my positive 3/2 slope. That's going to be here. I'm going to draw just a little dashed line. Okay, and then I also want to graph my slope of negative 3/2. So I'm going to go down 3 over 2. And I'm going to go up 3 over 2. That puts me here. And there's my slope of negative 3/2. Okay. And again, you don't have to draw this rectangle, but you want to check and make sure that those points came out to be lined up with your vertices there. If they didn't, then your slope might be upside down. Okay, so if this comes out to not be lined up right there, okay, if your vertices are not on that rectangle, your slope might be 2/3 and you might be upside down. Okay, so it's a good way to check and see. Okay, the last thing I need to do is draw my lines towards my asymptotes. And this way, and this way, and this way. I feel very architectural when we do these. Lots of drawings and preciseness and points and things. Good. Okay, any questions on that one? Okay. Okay, it's kind of hard flipping in your brain back and forth between ellipses and hyperbola because they have so many of those same points. So be sure you get some practice with those before the test. We still have a whole week until the test, but just be sure you get some practice, okay? All right, let's work 2 puzzle problems really quickly, and then we will be done for today. All right, so a couple of puzzle problems real quick. All right, again, I call them puzzle problems because I'm going to give you some pieces, and I want you to put them together in the formula to make the whole equation. Bless you. Okay, on the puzzle problems, they'll tell you if you're working with a circle, an ellipse, or a hyperbola. Right now, we're working all hyperbola. Okay, so that's what these will be, but it'll tell you. No, I'm going to work them just in your notes. Yeah, just in your notes on the puzzle problems. I'm sorry. Okay, these are going to be hyperbola. So let me tell you that we have a center point of 0, 0. I'm going to tell you that we have a vertex at 4, 0, and an asymptote equation of y equals plus or minus 1/2 x. Okay, so on a test situation, it would tell you this is a hyperbola, and then it would give you this information. Okay, so it will tell you what you're working with, which type of conic section, I should say. Okay, just like the ellipse, I like to start by doing a little bit of a sketch. Okay, so I'm not going to use a graph paper. It doesn't have to be anything precise, but I'm going to just kind of draw what they've given me. So I know that my center point is at 0, 0. Okay, and then I know that I've got one vertex over here at 4, 0. Okay, that just gave me 3 pieces of information. Okay, the first one is because I went from my center over to my vertex to the right, I know my hyperbola are going right and left. Okay, so I know that my hyperbola are going right and left. Okay, what that tells me is that x is going to be first. Okay, so when I go to write my equation here in just a minute, I know that x is first because my hyperbola are going right and left. Okay, all right, it also told me the distance between my center and my vertex, which I'm going to call a. Okay, what did they give me for my a value here? 4, that's right, good. And then the other thing they've given me is the center point up there. Okay, I could actually go over here and say I have another piece over here at -4 doing that if you want to. If it makes you feel good to have both ends drawn, that's what this thing's going to look like. Okay, because we're working at a center point of 0, 0, I would either take the answer as being x minus 0 squared or just x squared. So either way is fine with me for the first piece of this. Okay, so whichever way you want to write it is perfectly fine. But I know x is first, so I'm going to have x minus 0 squared over something. I'll come back to that. And y minus 0 squared over something, which is equal to 1. Again, if you want to just write this as y squared, that's okay with me too. Okay, but if you want to see that pattern of that center point being in there, you could write in the 0, 0s. It's completely your choice. Okay. With a hyperbola, I know that a is first. So with an ellipse, I know a is bigger, but with a hyperbola, I know a is first. So a squared will be 16. Okay, with a hyperbola, I know a is first. So a squared gives me 16. Okay, what I'm missing is b. Okay, what I'm going to use to find b is my asymptote slope up here. Okay, I know that my slope from my asymptote equation is 1/2. Because x is first, I know that my slope is b over a. Okay, because x is first, I know my slope is b over a. If I know that a is 4, what do I know b is? 2, that's right, good, because 2 over 4 would reduce back down to this 1/2. Okay, so now I know that b is equal to 2. Okay, and so if b is 2, b squared then is 4. Good. Okay, and on puzzle problems, that's all it's asking you to do is just fill in the equation. Okay, any questions on that one? By the way, if you run into one where you're coming out with a slope of 2 over 4 as you're working it, go ahead and leave that slope as 2 over 4, because if you reduce it, then your asymptotes don't line up with your vertices, okay? So if you want to write it as 1/2, that's fine, but you could leave it as 2 over 4. It'll make your picture a little nicer anyways. So it's the same thing. Okay, last one. Let's say that I tell you that the center is at 4, 2, and we have one vertex at 4, 4, and this time I'm going to tell you that there's a point that it goes through at 10, 6. Okay, so I'm going to give you all of that information. Okay, we worked one that was similar to this when we did a circle. Okay, so this is really similar to the one that we did with the circle. So you can look back and see that one too. Okay. All right, again, I'm going to start with just a little sketch. Okay, again, it doesn't have to be anything specific. I just want to kind of see what I'm working with here. So I'm going to start with my center at 4, 2 and my vertex at 4, 4. Okay, again, because my vertex is up from my center, I know that my hyperbola are going to be up and down. Okay, because my vertex is going up from my center point. Okay, that tells me a couple of things. First, it tells me that y is going to be first. Okay, so when I write my equation here in just a minute, I'm going to write y first. Okay. All right, the other thing it tells me is the distance from my center to one vertex. So how far is it from my center to one vertex here? 2, good. So I know A is 2. Okay, with hyperbola, A is the distance from the center to the vertex, and in this case, A is 2. Okay, I'm going to jump down here this time. So I know now that y is first. I know my center point, so I'm going to say y minus y squared over something, I'll come back to it, minus x minus 4 squared from my center, that's where I got the 4 from, over something is equal to 1. Okay, in a hyperbola, A is first, so my A squared of 4 is going to be first. Okay, what I'm missing here is B squared. Okay, what they've given me in my other piece of information is a point that I can use as x and y. Okay, so here's where this gets similar to that problem we worked with the circle. What I'm going to do is I'm going to fill in my 10 and my 6 for x and y, and then all I'll have left is b squared, and that's what I'm looking for. Okay, now be careful because they're opposites, so y needs to go first. So I'm going to have 6 minus 2 squared over 4, and I'm going to have 10 minus 4 squared over b squared is equal to 1. Okay, be very careful with the algebra. Most years when I see mistakes, it's algebraic mistakes. So be very careful with the algebra here. Okay, let's start with 6 minus 2 giving me 4, and 4 squared gives me 16, and 16 divided by 4 gives me 4 again. Okay, so 6 minus 2 was 4, 4 squared gave me 16, 16 divided by 4 is 4. All right, then over here I'm going to have 10 minus 4 gives me 6, 6 squared gives me 36 over b squared equals 1. Okay, now watch this algebra. Be careful right here. I'm going to subtract my 4 over to the other side. Okay, when I do that, I'm going to still be left with negative 36b squared. And what's going to happen when I do 1 minus 4 over on the other side? Negative 3, that's right. Okay, so subtract over the 4. Okay, and I'm going to put that negative 3 over 1. Do you remember what we do when we have two fractions that are equal? What do we do when we have two fractions that are equal to each other? What can we do? Cross multiply. That's right. Good. Okay, we can cross multiply. So I'm going to say that negative 3b squared is equal to negative 36. Okay, so what's b squared equal to? 12. Good. Okay, I need b squared. I don't need to take the square root of it. I actually need b squared. Okay, so I'm going to pop back up here to my formula, and I'm going to plug that in. So I'm going to have y minus 2 squared over 4 and x minus 4 squared over 12, which is equal to 1.